Welcome to Precalculus Concept 27D. Underneath graphs of sine and cosine, we're now going to focus our attention on the basic graph for cosine. There's three boxes. So here is box number 1. Now that we have a good understanding of the unit circle and what the unit circle is, since on our last class we practiced it, we're now ready to focus our attention on how the basic graph of cosine comes about. You may recall that the cosine of x deals with all of the x values of our triangle, since the cosine is the x over 1, or the adjacent over the hypotenuse. So what I'm going to do is I'm going to look at all of the x values. So I have a 1, I have a rad 3 over 2, I have a rad 2 over 2, 1/2, 0, negative 1/2, and then I'm going to keep going all the way around the unit circle here. Whoa, sorry. I am highlighting all of the x values, and we're going to use these x values to draw the cosine curve. Now, again, this is very, very, very similar to the sine curve. So what I'm going to do is I'm going to start at 0 radians. So I'll start with 0. Then I'll go over here to pi over 2. So I'll do 1, 2, 3, 4. Call this pi over 2. And then I'll go over here to pi. So I'll go 1, 2, 3, 4. Call it pi. Again, down here to 3 pi over 2. 1, 2, 3, 4. Call this 3 pi over 2. And I'm going to have to make this a little bit smaller and move it over. And I'll keep going, okay, like this. So 1, 2, 3, and then 4, finally back to 2 pi. So I really want you to understand that this, all the information between 0 and 2 pi, this is really everything in quadrant 1. All this information between pi over 2 and pi, this is everything in quadrant 2. All the information in between pi and 3 pi over 2, this is quadrant number 3. And then finally over here, this is quadrant number 4. I want to make sure that you understand that all we're doing is unraveling the unit circle in a linear fashion. The biggest that my x-coordinate can be is going to be a 1, so I'll make this, I'll go up 3 places and call that 1, and down 3 places and call that negative 1. Okay, so 1, 2, 3, yeah, perfect. So here we go. Okay, at 0, the x-coordinate, since I'm dealing with cosine, is worth 1, so I know 0, 1 is on the point. If I go all the way up to pi over 2, I have 0. If I go all the way over to pi, the x-coordinate is worth negative 1. If I go all the way over to 3 pi over 2, the x-coordinate is worth 0 again. And then if I come back around to 2 pi, which is the same thing as 0 radians, I'm back up here at 1. So you can clearly see if I was to connect each and every single one of these points, I would get this nice, beautiful curve. It looks very, very similar to the sine curve, except the starting point here is at 0, 1, whereas the sine curve was at 0, 0. It is to note that this thing keeps going, ladies and gentlemen, but we're only interested in kind of one revolution, which we'll get to later in the next video. So there's where the basic cosine curve comes from. Okay, box number 2 is how to do a quick sketch of the basic cosine curve. So we should be able to make this sketch in a moment's notice. So I'm going to have 0, I'm going to have pi over 2, I'm going to have pi, I'm going to have 3 pi over 2, and then I'm going to have 2 pi. I'm going to be up at 1 and then negative 1. So the 5 points that we need to be responsible for cosine are 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then 2 pi 1, and then be able to make that sketch. This is the drawing that we want to be able to create in a moment's notice to get our bearings straight for cosine curve. Okay, here are the important parts of a cosine curve. And we are only considering the domain from 0 to 2 pi. So just for this picture, not the domain, sorry, this picture only represents from 0 to 2 pi. So here are your 5 dots that I've given you on a nice, overlaid on a nice Desmos graph, so it's really pretty and easy to see, okay? The domain for the cosine curve is actually all real numbers, because remember, this graph does continue on to the left to the right, but right now we're only focusing from 0 to 2 pi. But really, I'm allowed to plug in any angle I want to this function, and I will be able to produce an output. The range, of course, is between negative 1 and 1. So that means like our highest point is at 1 and our lowest point is at negative 1. The x-intercepts are, there's one there at pi over 2. Here's another one at 3 pi over 2. So this is pi over 2. We could say 3 pi over 2. And then in general, it would be sort of every odd multiple of pi over 2. So like 1 pi over 2, 3 pi over 2, 5 pi over 2, sort of that thing. So in general, we say every odd multiple. The amplitude is the distance. Again, we're going to talk about this in a little bit more depth in the next video, but the amplitude is the distance from the midline to the highest point or the lowest point, which of course is a value of 1 in this case. The period is the exact same thing as it is for the sine curve. It is worth 2 pi. That means how many radians to complete one full revolution. And of course, it is to note that the cosine is an even function, meaning that it has symmetry about the y-axis. All right, there are the important parts of the cosine curve.